In this example, we want to take some real data and try to fit it to a mathematical equation, determine which model is better, and then use that model to answer some questions. Here we're comparing the age of a dog to human years. I used to hear, oh, it's like every year for a dog is like 7 human years. According to this, it's not quite that set. It's not exactly. So this is the table of data. I'm not exactly sure how they determined that, but we'll go with it, okay? So it says use your calculator to fit a linear function. We did that back in chapter 1, section 4. So we're going to review what we did there. So we turn on our calculator, get rid of all that stuff so it looks clean. And first thing is we're going to go over to stat and we're going to edit some information in. Now I've got some data in here, so I need to clear it out. Memory arrow up, hit clear and enter. Do the same thing for list 1, clear, enter, and now I can start clean. All right, so I'm going to put in my data here. So I'm going to put in 0.25, 0.51, 2, 4, 6, 8, 10, 14, 18, and 21. All right, go all the way back up to the top, and let's put in 2. Column 2, 5, 10, 15, 24, 32, 40, 48, 56, 72, 91, 106. And remember, the calculator's doing the hard work, so we have to be doing our work very carefully, double checking all my data, that I put the numbers in correctly. Looks like, all right, looks like I'm good. All right, so I'm going to quit from there. I'm going to go to y equals and make sure that my plot 1 is on. Okay, if you have any other equations, just like I did, clear it out. But you want your plot 1 on. Let's take a look to see what kind of shape we're dealing with. So we're going to quit. We're going to go to zoom, and we're going to go to zoom stat. And there it is. Well, it does kind of look linear, at least kind of in the middle, but like towards the first part, it's a little curved. Towards the end, it looks like it might curve up slightly. So let's see what the linear model looks like, how accurate it is. So I'm going to quit from here. We're going to go back to stat. And remember, you go to calculate now. We have to make the appropriate choice. So the first thing we're going to check is could it be modeled by a line? So linear regression. And I'm just going to go ahead and hit enter here. Not worried about pasting it anywhere at this point. And I look and ax plus b, so here's my a, I could round that to 4.55, b to 10.31, and I've got pretty good correlation coefficient in r squared. So in the past, when we were doing just lines, we could look at the correlation coefficient r. But when we get to other quadratic or cubic or higher degree types of regression, we won't get that r in our calculation. So we're going to have to compare instead the r squared. But the same rule applies. Is it closer to 1 or not? So this is good. I think that's a pretty good fit. So if I go here and I write down what it would be, 4.55x plus 10.31. All right, so I'm going to note there what my r was. So if I look at that again, the r squared is 0.991. That's pretty good. I'm going to make note of that. Now it says find a cubic. All right, and I already showed you what I got, but let's see how I got it. So I'm going to go back, clear this out, hit stat, and go over to calculate. This time I don't stop at linear regression. I go down to number 6 where it says cubic regression, and I hit enter again. It thinks a minute. Okay, now it gives me all these. So now I've got an A, a B, a C, and a D. So A goes with x cubed, B for x squared, C is the coefficient of x, and then D is our constant. Look at the r squared this time, 0.99, almost 7. So as good as the linear one was, this one's actually just a little bit better. And it's because, as we saw, there were a little bit of curves at the beginning of and end. Whatever MyMathLab asks you to do, you can round to whatever places it says. Just for our notes here, I rounded each of those to 2 decimal places. And make sure you understand where these numbers came from. I'm just looking at my screen and rounding off my coefficients. All right, so the next thing we're asked to do here, if I can move this down maybe, there we go, is determine which is better. We just said the cubic because r squared is closer to 1. And then the last question I put in here is to use the better model, which we are going to use the cubic model, to estimate the equivalent human age for a dog that's 7 years old. All right, so what would I do? Well, I could use my rounded one, or if I want to use the more precise one, I could go through all of that again, do L1, L2, Y1, or here's another way of getting it pasted. So you go to your Y equals menu, and we're going to go to our VARs menu, and say we want to do some statistical stuff here. So hit enter on statistics. What do we want? We want the equation. We want the regression equation. So we're telling it to paste that regression equation here in my Y1. All right, so I'm going to quit from there. And then I can use that. So I'm going to go to vars, Y variable, function, Y1, and we want that of 7. Hit enter. It's about 45 years. So I think that's what I got when I did this before. Yep, 45 years old is a 7-year-old dog. If you have any questions, please don't hesitate to reach out to me.